Hello again. It's come to my attention that page 123 of the notes is not complete. I'll send this out as a photograph, but example 1, it's kind of just walking you through the steps of differentiation from first principles without actually asking you to do it. And so if you look at the question, it's got a curve. It's a quadratic, obviously. We've got points A and B, but we're told that the x-coordinate is 2 instead of x, and so and that the x-coordinate of B is 2 add h. So in terms of find in terms of h the gradient of AB, well, you've got 2 points, or you've got the x-coordinate of 2 points. So if we find the corresponding y-coordinates, so here x squared takes 6x add 5 when x is 2 add h gives you this, and then we just want an expression for the gradient of the line that between the 2 points, which goes to this. So it doesn't actually ask you for the gradient at A, and this is the whole principle of differentiation. We're finding the gradient of this chord AB when h is some amount. But by minimising that value, i.e. Considering it tending towards 0, the chord AB becomes the tangent at A. So we are actually finding, as h tends to 0, the gradient at A. This one leads you through, first of all, change that 5 to a 4. I changed that because you wouldn't get a power that high to do this stuff. And it's unless they combined it with the binomial expansion question, but I couldn't see that happening. So I did actually use the binomial expansion to do all of this. So quite tediously, the y-coordinate of B is that, because if we put in 3 add h to 2x to the 4, that's what we get. A has a y-coordinate of 162, and then it's just an expression again for the gradient of AB. These are the steps you take when you're differentiating from first principles, but it's scaffolded. The question's been scaffolded and given you sort of step by step. So we end up with this, and so that would be an expression for the gradient of AB if the distance, the horizontal distance between A and B is some amount h. If that amount tends towards 0, then what we get is the gradient of the curve at the point A, because that would be the gradient of the tangent at A. And so there, if all of these 3 terms become 0, the gradient at A must be the constant 216, which makes sense because now you know a bit about differentiation. You would differentiate this and get 8x cubed, and if you substitute x is 3 into 8x cubed, you ought to get 216. Okay, so could you fill that page out, please? I won't ask you to send it me, I'm going to trust that you will do that, but can you just fill that page 123 out? That'd be great. Thank you.